Hello class, in this video we're going to look at solving equations in two steps. So the thing I'm going to want you to remember when trying these examples and throughout the course of this video is to remember your order of operations. When we tackle these problems, we're going to be using order of operations in reverse. This wasn't so important when we were solving them in one step because we were just using the inverse of whatever operation was initially given to us, but I did mention it because it was important. So that means we're going to look for addition or subtraction that is in the problem. And here we see we have a plus 3. Like we did with one step, we're going to use the inverse to subtract it. Okay, I got 2x equals 12. And now we can deal with the multiplication last using the inverse and dividing by 2. That cancels and we get x equals 6. Now let's go ahead and check. Again, when we did this in one step, it was kind of trivial to show our work, but I was wanting to emphasize habits then. That's what we're building on now. So I'm going to type in 2 times 6 plus 3. And when we're checking, we just use good old-fashioned order of operations. So the multiplication comes first. 2 times 6 is 12. And then plus 3 is 15, which is what we had in the original equation. So we're done. Okay, so let's look at our second example. We have x over 8 minus 4 equals 2. Again, we start by looking for addition and subtraction. We have this minus 4. So for inverses, I'm going to write plus 4 on both sides. So I'll get left with x over 8 on the left side, and then 2 plus 4 is 6. Okay, great. Now we're dealing with division with the x divided by 8. So remember, we are multiplying in this instance, both sides. Cancel out the 8s, we end up with x equals 48. So let's go ahead and check our answer. We get 40. Oh, there we go. 48. It'll work, I promise. Divided by 8 minus 4. So we know that 48 divided by 8 is 6. Minus 4 is 2, which is what we had here. And so we're done. Okay. So these are the problems that I want you to pause the video and give it a chance really quickly. And then when you're ready, type your answers into the solution box and we'll go from there. Okay, so again, reverse order of operations. I'm looking for addition first or subtraction. I have a plus 1 here. So I'm going to subtract that 1. I get 3x equals 15. And then I'll deal with the multiplication by dividing. And I get x equals 5. Not as much room on this page, but we'll go ahead and check anyway. 3 times 5 plus 1. We know that 3 times 5 is 15. And then plus 1 is 16. Okay. All right, so our next problem. Now we have a subtraction here. This is a little bit out of order than what we're used to dealing with. We have 2 minus 3x equals 17. We have a positive 2. When we look for reverse order of operation, what step to do first, notice we've always tackled the constant before we tackled the coefficient with the variable. So we're going to start with this 2, and we're going to subtract it. Okay. So we'll cancel that out, and we have to remember when we drop this down, that is a negative 3x that is equal to 15, and then we divide by a negative 3. We can't lose that minus sign or else our answer is going to be wrong. And this is why we check our work. If you forgot that negative, pardon me, if we forgot that negative, we'd get the wrong answer, but we discover it when we check our work. So divide by negative 3, we get x equals negative 5. And so we get 2 minus 3 times negative 5 in our check. Remember, this is a negative 3 times a negative 5 gives us a positive 15. So 2 plus 15 is 17, and we're good. All right. Last example. Once again, we've got this minus 3 here, so we'll go ahead and add 3 to both sides. We get 8 is equal to t over 2. And remember, t over 2, that's division, so we're multiplying by 2. And we get 2 times 8 is 16 equals t. So our final answer is 16. Let's go ahead and check that. We get 16 divided by 2 minus 3. 16 divided by 2 is 8. Minus 3 is equal to 5. And we're good. All right. So now let's take a look at a special kind of example. Here we have x minus 7 in the numerator of a fraction. All of it divided by 3 equals negative 12. Now, in the past, we have learned to separate this into two different fractions, and then we could use reverse order of operations. This is kind of a instance where we need to think of this x minus 7 as being in parentheses, okay? Which, when we think about order of operations and wanting to tackle them in reverse, would mean this step would go last. That's very important to understand this problem and doing it correctly. So we're really tackling that division first, which means we're going to multiply both sides by 3, and then this cancels. Now we're just left with the x minus 7, and we can drop those parentheses. We get negative 12 times 3 is equal to negative 36. Hey, it looks like a little heart. That's on accident. And then we're dealing with our subtraction that was in the parentheses formerly. So remember, we're dealing with this step now, and we'll add 7. So x, negative 36 plus 7 is negative 29. And we have our answer. So let's go ahead and substitute that back in and check. We would have negative 29 minus 7 divided by 3. And again, this numerator is like it's in parentheses, so we deal with that first. Negative 29 minus 7 is a negative 36. And then we divide by the 3, and we get negative 12. And we're good. So go ahead, try this problem on your own real quickly, and then restart the video when you're ready to see the answer. Okay, so let's go ahead and start by multiplying by 4. Multiplying by 4 on both sides. That cancels this. Again, remembering this x minus 2 that's in the numerator, we're thinking of that being in parentheses. Reverse order of operations means we deal with that last. So 4 times 6 is 24. And then we just have the x minus 2. And now we can add 2 to both sides. And we get 26 equals x. Okay. Let's go ahead and substitute that back in and check our answer. So we get 26 minus 2, all of that in the numerator, divided by 4. We deal with the 26 minus 2 first, that's 24. And then divide by the 4, we get 6, and that checks out. All right, let's give a word problem a chance. You are making a bulletin board to advertise community service opportunities in your town. You plan to use half a sheet of construction paper for each ad. You need 5 sheets of paper for a title banner. You have 18 sheets of paper. How many ads can you make? All right, so we're going to need to write an equation for this. Let's write it out in words first. We need half a sheet of construction paper. So we say 1/2 times paper You can write construction paper if you want, but that might just be too much to write. And then we need 5 sheets total for the banner, okay? And we have 18, so we want to know how many total sheets can we use that's left over to make our ads, okay? So if we were to rewrite this, 1/2 just P plus 5 equals 18. We'll go ahead and start by subtracting our 5. We get 1/2 P. You could also think of that as P over 2 equals 13. And we multiply by 2. And we get P is equal to 26. And of course, we'll label our answer. That is ads. Now, if we're going to check our answer, we're plugging that 26 back. I probably should have used ads as the variable, not paper. That was incorrect, but that's okay. Just as long as we're setting up the correct equation correctly, we are following through and we're labeling our answer properly. Let's go ahead and it's 1/2. Find a place on this screen that will write. What the heck? All right, there we go. I got it written out. There we go. 1/2 times 26, that's 13. And plus 5 is 18. There we go. And we're good. Okay. So go ahead and give the next problem a try. We're operating off the same information from the previous problem. So if you need to refer back to that problem in your notes, please do that. And I'll see you in a few minutes. All right, so this question says, suppose you use 1/4 sheet of paper for each ad and 4 full sheets of paper for the title banner. So let's reflect on what our equation was previously. It was 1/2 P plus 5 equals 18. Now the problem does not change the amount of paper we have. We still have 18. So that 18 on the right side, that's good. But we are going to be changing this 5. We now only need 4 sheets of paper for the title banner. So that's 4. And now we only need 1/4. So we're going to change this 1/2 to 1/4. And now we can follow the same steps. We're going to start by subtracting 4. We got 1/4 P is equal to 14. Now we times by 4. We get P is equal to 56. And now we can start looking at checking our answer. So 1/4 times 56 plus 4. 1/4 times 56, so that is 14. Plus 4 is 18. We're good. All right. Last example, what is the solution of negative t plus 8 equals 3? Justify each step. So we're going to go through a new way to solve these. And since we're going to be justifying each step along the way, I'm not going to have us check it at the end. The division will, or the justifications will take up enough time as is and can act as a new way of checking our work to make sure we did everything correctly. So what I'm going to do is I'm going to create myself a table. So this is my solution. I'll abbreviate that. And then my justification. Or you can say reason. I probably should have just said reason. That's okay. All right, so we got negative t plus 8 equals 3. Okay, so this is, we're going to say this is given. Okay, that's the original problem. Traditionally in math, we just say given. Okay, so our first step is we're going to subtract 8 from both sides. And we got negative t is equal to negative 5. Now, we got to give 2 justifications for this because we subtracted originally. So that will be one justification, subtraction Okay. And then we combined the 3 minus 8. We actually did the calculation. This would just be a simplification. We could also say combining like terms, but that's too much writing. All right. Last step. We got to remember negative t is like we have a negative 1 in front. So we're going to divide by negative 1. You could also multiply by negative 1, but division is the traditional step. And so we get t is equal to 5. So again, 2 steps. We divided, so division, and then we simplified. Okay. So that's all we need to do. I mean, we didn't do anything special with our justification. We just described what we're doing. And this kind of leads us to the idea that we always are justifying something in some way, but writing it down and making us look at, okay, this is precisely what we did, can help form a more concrete understanding. So, last problem, go ahead and you attempt this one, and then we will go over the answer, and then you're done. Okay, so let's set up our table. This is our solution. And this time I'll say reason instead of justification, even though justification sounds more technical. All right, so we got x over 3 minus 8 equals negative 4. That's always given to us. All right, so we'll start with adding 8 to both sides. All right, and then this cancels. We get x over 3. Negative 4 plus 8 is 4. So this was addition. And then we simplified. And then we went ahead and we're going to multiply by 3 to cancel out that division. And we get x equals 12. We'll go ahead and put multiplication. There we go. And then we simplified once again. Thanks for watching. Oh, so bad.